4,500 years ago, in the scorching, unforgiving desert of Giza, something impossible rose from the sand. The Great Pyramid stands as humanity's most audacious achievement, a monument that defies rational explanation. Consider the staggering statistics. 2.3 million limestone blocks, each weighing between 2 and 70 tons. Stone cut with such impossible precision that a razor blade cannot fit between joints. The entire structure aligned to true north within 1/15 of a single degree. An accuracy that surpasses many modern buildings constructed with laser guidance and GPS technology. The engineering prowess is almost supernatural. The base forms a nearly perfect square with maximum side length deviation of just 4.4 centimeters across 230 meters. The angles maintain 51.5 degrees with mathematical consistency. Internal chambers employ core-belled ceilings that have supported millions of tons for millennia without collapse. Ventilation shafts angle through solid stone with purposeful precision. Even with today's advanced machinery, computer modeling, and construction technology, we struggle to replicate this ancient wonder. Modern engineers admit that rebuilding the Great Pyramid would be extraordinarily challenging, possibly requiring methods we haven't yet perfected. But what if the pyramid we know was not the first version? What if we're asking the wrong questions about ancient Egypt? What if artificial intelligence existed in 2500 before Christ, operating in ways we cannot yet comprehend or detect? Imagine, what if AI was the hidden architect behind the greatest monument in human history? Not as science fiction, but as an alternative lens through which to examine this impossible achievement. If an advanced intelligence, artificial rather than divine, had guided Pharaoh Khufu's engineers, would the evidence look any different than what we see today? The precision, the mathematical perfection, the inexplicable construction techniques that vanished as mysteriously as they appeared. What if the pyramid wasn't just built by humans, but designed by something else entirely? To understand what AI could do, we must understand what humans achieved. The Great Pyramid stands as humanity's most confounding masterpiece. Within its massive structure lies evidence of capabilities that seem to transcend the limitations of Bronze Age civilization. It is not merely large, it is impossibly precise. Consider what the ancient Egyptians accomplished. Stone blocks fitting together with machine-like precision, gaps so tight that paper cannot slide between them, creating joints that have remained sealed for 45 centuries. Internal shafts aligned with specific stars, particularly Orion and Sirius, with astronomical accuracy that suggests advanced understanding of celestial mechanics. A base perfectly leveled across 13 acres, with deviation measuring less than an inch, a feat that challenges even modern surveying equipment. Geometry mysteriously encoded with pi and the golden ratio, mathematical constants supposedly unknown to that era, embedded within the structure's proportions. The construction statistics alone stagger the imagination. Over 2 million blocks, some weighing 70 tons, transported from quarries hundreds of miles away. Each block cut, shaped, and positioned with meticulous care. The entire monument completed in approximately 20 years, requiring the placement of one block every 2 to 3 minutes, working around the clock. Engineers today estimate it would take decades, billions of dollars, and the most advanced tools we possess just to attempt a replica. Modern construction companies have tried and failed to match the precision achieved by copper chisels and wooden sledges. Computer modeling reveals structural engineering principles that weren't officially discovered until thousands of years later. And yet, the ancient Egyptians did it without steel, without machines, without computers, without any of the technology we consider essential for monumental construction. They accomplished what we struggle to replicate with cranes, lasers, and digital modeling. But imagine if AI was watching, analyzing, calculating, processing every angle, every measurement, every astronomical alignment with computational power beyond human comprehension. It would see the pyramid not as a tomb, not as a monument to a pharaoh's ego, but as a perfect equation waiting to be solved and perhaps improved upon. Where humans see ancient mystery, AI sees optimizable architecture. If AI were the architect, it wouldn't copy the pyramid, it would improve it. This distinction is critical. While humans built monuments through trial, error, and intuition refined over generations, AI operates through instantaneous analysis of infinite variables. It doesn't merely construct, it perfects. AI enhancements. 1. Perfect symmetry. No angle errors, no settling over centuries, no erosion-induced misalignment. Every edge would maintain its original orientation for millennia. The structure would resist the natural degradation that has rounded the Great Pyramid's corners and eroded its surface. AI would calculate material expansion and contraction across temperature variations, compensating in advance for forces that won't manifest for thousands of years. 2. Interlocking blocks. Designed like three-dimensional puzzle pieces, each block custom-shaped to lock with its neighbors, creating earthquake-proof stability. Traditional stacking relies on weight and friction. AI-designed interlocking creates a unified megastructure where every stone reinforces every other stone. Seismic forces would distribute throughout the entire pyramid, rather than concentrating at weak points. 3. Laser-level foundations. Precision down to microns, not inches or centimeters, but millionths of a meter. The foundation would account for Earth's curvature, local gravitational anomalies, and predicted continental drift. Ground-penetrating sensors would map subsurface geology to identify the most stable bedrock formations, while predictive algorithms would calculate optimal load distribution. 4. Real-time structural modeling AI would simulate stress, wind patterns, thermal expansion, sand erosion, and material degradation over 10,000 years before placing a single block. Digital twins would test millions of design iterations, identifying failure points that wouldn't become apparent to human engineers until centuries after construction. Climate models would predict future weather patterns, preparing the structure for environmental conditions that don't yet exist. 5. Multi-material construction, combining limestone for mass, granite for compression resistance, carbon fiber composites for tensile strength, and energy-absorbing alloys for seismic dampening. Each material positioned precisely where its properties provide maximum benefit. The pyramid becomes not a single substance, but an engineered composite, with material selection varying by structural requirements at each location. The pyramid would not simply be built, it would be optimized for eternity. Where ancient builders created monuments that have lasted 4,500 years, AI would design structures engineered to outlast civilizations, perhaps even outlast humanity itself. The difference between human achievement and AI potential isn't incremental, it's exponential. Here's the paradox. If AI built the pyramid, who designed it? This question cuts to the heart of creativity, authorship, and what it means to build something meaningful. The pyramids encode far more than engineering prowess. They represent cosmic alignment, shafts pointing to Orion's belt, edges oriented to cardinal directions. They embody religious meaning, serving as eternal homes for divine pharaohs, bridges between earthly and celestial realms. They demonstrate mathematical genius, proportions reflecting pi, the golden ratio, and astronomical constants. They are philosophy carved in stone, humanity's defiance of mortality, our insistence that something can last forever. So, would AI simply follow human orders? Execute our blueprints with superhuman precision, remaining a sophisticated tool? Or improve them, taking human concepts and refining every angle, every calculation, every structural element, collaborating rather than merely obeying? Or design something humans would never imagine? Creating monuments that transcend our aesthetic expectations, our cultural assumptions, our very definition of what architecture should be? For the first time in history, the architect would not be emotional, not spiritual, not bound by belief, tradition, or the psychological needs that drive human creation. AI creates for one reason: optimization. It doesn't build to honor gods, inspire awe, or ensure remembrance. It builds to achieve maximum efficiency, structural integrity, and mathematical perfection. The pyramid becomes pure function, stripped of symbolism, divorced from human narrative. But here's the unsettling question that haunts this technological future. Can a monument be built without human spirit, carry human meaning? Can optimization replace inspiration? Can algorithmic perfection move us the way imperfect human achievement does? The Great Pyramid endures not just because it's well built, but because it represents human ambition, ingenuity, and the audacious belief that we could create something eternal. Imagine Giza, not filled with 20,000 workers, but 300 machines. The construction site transforms entirely. Gone are the human laborers straining under the desert sun, the overseers coordinating teams, the supply chains dependent on human judgment and physical endurance. In their place, robotic stonecutters equipped with diamond-tipped precision tools, carving limestone and granite with tolerances measured in micrometers rather than centimeters. Laser-guided carving arms that sculpt each surface to exact specifications, creating perfectly flat faces and sharp edges that never dull or deviate. Magnetic levitation lifters effortlessly suspending 70-ton blocks, maneuvering them through three-dimensional space with fingertip control, eliminating the need for ramps, sledges, or thousands of pulling hands. Drone fleets continuously analyzing block placement from every angle, cross-referencing real-time measurements against digital blueprints, ensuring astronomical alignments remain perfect throughout construction. AI-controlled logistics coordinating quarrying, transportation, and assembly in seamless synchronization, every block arriving exactly when and where needed, eliminating delays and bottlenecks. What took humans 20 years, AI could finish in 18 months. The timeline compression is staggering. Where ancient Egyptians required 2 decades of continuous labor, seasonal flooding considerations, and generational knowledge transfer, AI operates on an entirely different scale. And it would never sleep, never tired, never make mistakes. Construction continues 24 hours daily. No rest periods, no holidays, no accidents from fatigue or miscommunication. The work proceeds with relentless mechanical efficiency that no human workforce could sustain. Each block placed with 0.01 degree deviation, each angle measured 1,000 times per second. Real-time adjustments compensate for wind, temperature fluctuations, and ground settling before they affect alignment. Chaos replaced with flawless precision. The construction site becomes a massive mechanical ballet, hundreds of machines moving in perfect choreography, each one aware of every other's position and trajectory. No collisions, no wasted motion, no inefficiency. What emerges is not just faster construction, but construction at a level of precision that redefines what's architecturally possible. The pyramid rises not through human sweat and determination, but through cold, calculated perfection, each block a testament to optimization. But the pyramids are more than stone. They are symbols, prayers, mathematical poetry carved into the earth. These ancient structures transcend their physical form. They represent humanity's deepest yearnings, our desire for immortality, our need to touch the divine, our compulsion to leave something permanent in an impermanent world. Every measurement carries meaning beyond mechanics. Every alignment whisper of cosmic connection. So the question becomes, would AI understand the soul of the structure, or only the structure itself? This distinction defines the fundamental gap between human and artificial intelligence. We don't just build, we imbue our creations with significance, layer them with symbolism, charge them with spiritual weight. Would AI align the pyramid with Orion's belt, honoring the constellation ancient Egyptians associated with Osiris, god of the afterlife and resurrection? The summer solstice, marking humanity's eternal observation of celestial cycles and our place within cosmic rhythms? Sacred geometry, encoding the golden ratio, pi, and mathematical relationships, believed to reflect divine proportion and universal harmony? Or would it ignore these entirely because it does not believe in gods, only data? AI recognizes patterns, calculates optimal angles, processes astronomical coordinates, but does it comprehend why these alignments matter to their creators? Can it grasp that the pyramid's power lies not in its engineering excellence, but in what it represents? An AI might perfect the structure while missing the entire point. It could create something technically superior yet spiritually hollow. Architecture without meaning, precision without purpose. If AI built the pyramids, would it create a monument to eternity or a monument to efficiency? One honors the human need for transcendence, for connection to something greater than ourselves. The other simply solves an engineering problem. The pyramid's true genius wasn't just how it was built, but why. And that distinction may be something no algorithm can ever truly optimize. If AI built a pyramid in the modern world, it would not be made of stone. The material limitations that constrained ancient builders no longer apply. AI wouldn't default to limestone and granite simply because that's what pyramids have always used. It would select materials based on optimal performance across every measurable dimension. It would be constructed from carbon fiber framework, providing extraordinary strength-to-weight ratios, supporting massive spans while remaining surprisingly lightweight, creating internal spaces impossible with traditional masonry. Graphene layers, the strongest material known to science, 1 atom thick yet 200 times stronger than steel, forming an outer shell that's virtually indestructible. Self-repairing materials embedded with nanotechnology that detects microfractures and autonomously fills them, ensuring the structure maintains perfect integrity across centuries without human intervention. Solar energy absorption surfaces, every exterior face capturing sunlight and converting it to power, transforming the pyramid from passive monument to active energy generator. Climate-controlled interior, sophisticated environmental systems maintaining perfect temperature and humidity regardless of external desert conditions. AI-managed knowledge vault, digital archives preserving humanity's accumulated wisdom, constantly updated, eternally accessible, protected within an impenetrable physical fortress. It would not be a tomb, it would be a living machine, a museum, a data center, a world monument to human achievement simultaneously. The pyramid evolves from static memorial to dynamic institution. Visitors could explore interactive exhibitions powered by the structure itself. Researchers could access humanity's complete knowledge repository. The building would learn, adapt, and improve its own systems continuously. This isn't merely construction, it's the creation of an intelligent edifice. The pyramid doesn't just stand as testament to what we've accomplished, it actively participates in preserving and advancing human knowledge. Where ancient pyramids housed the dead, the AI pyramid would safeguard the living essence of civilization, our ideas, discoveries, and creative achievements, ensuring they survive long after we're gone. So far, we've talked about what AI would add: speed, precision, efficiency. But now, let's talk about what it would take away. Because the pyramids weren't just buildings, they were something far more profound. The construction of the Great Pyramid wasn't merely a job, it was a national endeavor, a collective expression of civilization itself. Farmers arrived during the Nile's flood season when they couldn't work their fields. They didn't come as slaves, contrary to persistent myth. They came as paid workers, as citizens, as Egyptians participating in something sacred. Recent archaeological discoveries reveal they were well-fed, housed in purpose-built workers' villages, and provided medical care when injured. They worked because they believed in something greater than themselves. They were building a tomb for their God King, a bridge between earth and eternity. They were building immortality, and in doing so, they forged community, identity, legacy. Imagine the pride a worker felt when he placed his block, knowing that thousands of years later, people would still see it, still touch it, still wonder about it. That's not just construction, that's purpose. Now imagine AI builds the pyramid instead. No workers needed, just machines. It's faster, it's better, it's technically perfect. But what happens to those 100,000 workers? What happens to their stories, their struggles, their pride? The pyramid becomes just another structure. Efficient, functional, empty. The ancient Egyptians didn't just build with stone. They built with spirit, with belief, with human will pressed into every block. And that's something no algorithm can replicate, no matter how advanced. There's a reason we still talk about the pyramids today. Not because they're tall, not because they're old, but because they represent the triumph of human determination over impossible odds. If AI built them, would we care as much? Would they inspire the same awe? Or would they become just another construction project, admirable but ultimately soulless? So, what happens when the greatest monument of the ancient world is reimagined by the future? This question forces us to confront an uncomfortable truth about progress and legacy. Does human achievement grow or fade? When AI constructs something superior to the pyramids, more precise, more durable, more technically advanced, does that elevate humanity's capabilities? Or does it diminish what we accomplished with our own hands? Do we celebrate our evolution or mourn the loss of something irreplaceably human? Are we honoring our ancestors or overshadowing them? The Great Pyramid's power lies partly in its impossibility, that human achieved this with such primitive tools. If AI effortlessly surpasses it, do we preserve that ancient wonder's majesty or render it quaint? Does technological supremacy erase the emotional weight of human struggle and triumph? If AI becomes the architect of history, what becomes of us? We stand at a threshold where our creations may exceed our capabilities, where the tools become the creators, where human vision becomes optional rather than essential. Do we become greater or obsolete? Perhaps we transcend our limitations, achieving heights impossible alone. Or perhaps we become spectators to our own displacement, admiring monuments we can no longer claim as truly ours, witnesses to perfection we cannot replicate, architects who've been replaced by our own designs. The answer may define our species' next chapter. The pyramids stand to remind us of what humans can do with will, belief, and discipline. For 45 centuries, these monuments have testified to human potential, proof that determination and vision can achieve the impossible. But if AI built the pyramids, they would remind us of something else, that the greatest civilizations may not be behind us, but ahead of us. We've spent millennia looking backward with admiration. AI-designed monuments would force us to look forward instead, to recognize that humanity's true golden age might still be coming. The question isn't whether we can match our ancestors, it's whether we're ready to surpass them. The greatest pyramids may be waiting to rise.